The Lockheed SR-71, Blackbird, is a long-range, high-altitude, Mach 3 plus strategic reconnaissance aircraft developed and manufactured by the American aerospace company Lockheed Corporation. It was operated by both the United States Air Force and NASA. The SR-71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft during the 1960s by Lockheed's Skunk Works division. American aerospace engineer Clarence Kelly Johnson was responsible for many of the aircraft's innovative concepts. The shape of the SR-71 was based on that of the A-12, which was one of the first aircraft to be designed with a reduced radar cross-section. At one point, a bomber variant of the aircraft was under consideration, before the program was focused solely on reconnaissance. Mission equipment for the reconnaissance role included signals intelligence sensors, side-looking airborne radar, and a camera. The SR-71 was both longer and heavier than the A-12, allowing it to hold more fuel as well as a two-seat cockpit. The State Route 71 designation has been attributed to lobbying efforts by USAF Chief of Staff General Curtis LeMay, who preferred the SR, Strategic Reconnaissance, designation over simply RS, Reconnaissance, Strategic. The aircraft entered service in January 1966. During aerial reconnaissance missions, the State Route 71 operated at high speeds and altitudes, allowing it to outrace or entirely avoid threats. If a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outpace the missile. On average, each State Route 71 could fly once per week due to the extended turnaround required after mission recovery. A total of 32 aircraft were built. 12 were lost in accidents with none lost to enemy action. During 1988, the USAF retired the State Route 71 largely for political reasons. Several were briefly reactivated during the 1990s before their second retirement in 1998. NASA was the final operator of the Blackbird, retiring their aircraft in 1999. Since its retirement, the SR-71's role has been taken up by a combination of reconnaissance satellites and unmanned aerial vehicles. A proposed UAV successor, the SR-72, is under development by Lockheed Martin, and scheduled to fly in 2025. The State Route 71 has several nicknames, including Blackbird and Habu. As of 2022, the State Route 71 still holds the world record it set in 1976 as the fastest air-breathing manned aircraft, previously held by the related Lockheed YF-12. The SR-71 was designed for flight at over Mach 3 with a flight crew of 2 in tandem cockpits, with the pilot in the forward cockpit and the reconnaissance systems officer operating the surveillance systems and equipment from the rear cockpit, and directing navigation on the mission flight path. The SR-71 was designed to minimize its radar cross-section, an early attempt at stealth design. Finished aircraft were painted a dark blue, almost black, to increase the emission of internal heat and to act as camouflage against the night sky. The dark color led to the aircraft's nickname, Blackbird. While the State Route 71 carried radar countermeasures to evade interception efforts, its greatest protection was its combination of high altitude and very high speed, which made it almost invulnerable. Along with its low radar cross-section, these qualities gave a very short time for an enemy surface-to-air missile site to acquire and track the aircraft on radar. By the time the SAM site could track the SR-71, it was often too late to launch a SAM, and the State Route 71 would be out of range before the SAM could catch up to it. If the SAM site could track the SR-71 and fire a SAM in time, the SAM would expend nearly all of the delta V of its boost and sustainer phases just reaching the SR-71's altitude. At this point, out of thrust, it could do little more than follow its ballistic arc. Merely accelerating would typically be enough for an State Route 71 to evade a SAM. Changes by the pilots in the SR-71's speed, altitude, and heading were also often enough to spoil any radar lock on the plane by SAM sites or enemy fighters. At sustained speeds of more than Mach 3.2, the plane was faster than the Soviet Union's fastest interceptor, the Mikoyan-Gurevich MiG-25, which also could not reach the SR-71's altitude. During its service life, no SR-71 was ever shot down. The airplane is 92% titanium inside and out. Back when they were building the airplane, the United States didn't have the ore supplies, an ore called rutile ore. It's a very sandy soil and it's only found in very few parts of the world. The major supplier of the ore was the USSR. Working through third world countries and bogus operations, they were able to get the rutile ore shipped to the United States to build the State Route 71, the second operational aircraft designed around a stealth aircraft shape and materials. After the Lockheed A-12, the State Route 71 had several features designed to reduce its radar signature. The State Route 71 had a radar cross-section around 110 square feet. Drawing on early studies in radar stealth technology, which indicated that a shape with flattened, tapering sides would reflect most energy away from a radar beam's place of origin, engineers added chines and canted the vertical control surfaces inward. Special radar-absorbing materials were incorporated into sawtooth-shaped sections of the aircraft's skin. Cesium-based fuel additives were used to somewhat reduce exhaust plumes' visibility to radar, although exhaust streams remained quite apparent. Kelly Johnson later conceded that Soviet radar technology advanced faster than the stealth technology employed against it. The State Route 71 featured chines, a pair of sharp edges leading aft from either side of the nose along the fuselage. These were not a feature on the early A-3 design. Frank Rodgers, a doctor at the Scientific Engineering Institute, a CIA front organization, discovered that a cross-section of a sphere had a greatly reduced radar reflection, and adapted a cylindrical-shaped fuselage by stretching out the sides of the fuselage. After the advisory panel provisionally selected Convair's fish design over the A-3 on the basis of RCS, Lockheed adopted chines for its A-4 through A-6 designs. Aerodynamicists discovered that the chines generated powerful vortices and created additional lift, leading to unexpected aerodynamic performance improvements. The angle of incidence of the delta wings could be reduced for greater stability and less drag at high speeds, and more weight carried, such as fuel. Landing speeds were also reduced, as the chines vortices created turbulent flow over the wings at high angles of attack, making it harder to stall. The chines also acted like leading-edge extensions, which increased the agility of fighters such as the F-5, F-16, F/A-18, MiG-29, and Su-27. The addition of chines also allowed the removal of the planned Canard foreplanes. The SR-71 was powered by two Pratt & Whitney J58 axial flow turbojet engines. The State Route 71 also required in-flight refueling to replenish fuel during long-duration missions. Supersonic flights generally lasted no more than 90 minutes before the pilot had to find a tanker. Specialized KC-135Q tankers were required to refuel the SR-71. The KC-135Q had a modified high-speed boom, which would allow refueling of the Blackbird at nearly the tanker's maximum airspeed with minimum flutter. The tanker also had special fuel systems for moving JP-4, for the KC-135Q itself, and JP-7, for the SR-71, between different tanks. As an aid to the pilot when refueling, the cockpit was fitted with a peripheral vision horizon display. This unusual instrument projected a barely visible artificial horizon line across the top of the entire instrument panel, which gave the pilot subliminal cues on aircraft attitude. Nortronics, Northrop Corporation's electronics development division, had developed an astro-inertial guidance system, which could correct inertial navigation system errors with celestial observations, for the SM-62 Snark missile, and a separate system for the ill-fated AGM-48 Skybolt missile, the latter of which was adapted for the SR-71. Before takeoff, a primary alignment brought the ANS's inertial components to a high degree of accuracy. In flight, the ANS, which sat behind the reconnaissance systems officer's position, tracked stars through a circular quartz glass window on the upper fuselage. Its blue light source star tracker which could see stars during both day and night, would continuously track a variety of stars as the aircraft's changing position brought them into view. The system's digital computer ephemeris contained data on a list of stars used for celestial navigation. The list first included 56 stars and was later expanded to 61. The ANS could supply altitude and position to flight controls and other systems, including the mission data recorder, automatic navigation to preset destination points, automatic pointing and control of cameras and sensors, and optical or SLR sighting of fixed points loaded into the ANS before takeoff. According to Richard Graham, a former State Route 71 pilot, the navigation system was good enough to limit drift to 1,000 feet off the direction of travel at Mach 3. The State Route 71 originally included optical, infrared imagery systems, side-looking airborne radar, electronic intelligence gathering systems, defensive systems for countering missile and airborne fighters, and recorders for SLAR, ELINT, and maintenance data. The State Route 71 carried a Fairchild tracking camera and an infrared camera, both of which ran during the entire mission. As the State Route 71 had a second cockpit behind the pilot for the RSO, it could not carry the A-12's principal sensor, a single large focal-length optical camera that sat in the Q bay, behind the A-12's single cockpit. Instead, the SR-71's camera systems could be located either in the fuselage chines or the removable nose chine section. Wide-area imaging was provided by two of ITEC's operational objective cameras, which provided stereo imagery across the width of the flight track, or an ITEC optical bar camera, which gave continuous horizon-to-horizon coverage. A closer view of the target area was given by the HYCON technical objective camera, which could be directed up to 45 degrees left or right of the centerline. Initially, the TEOCs could not match the resolution of the A-12's larger camera, but rapid improvements in both the camera and film improved this performance. Flying at 80,000 feet meant that crews could not use standard masks, which could not provide enough oxygen above 43,000 feet. Specialized protective pressurized suits were produced for crew members by the David Clark Company for the A-12, YF-12, M-21 and SR-71. Furthermore, an emergency ejection at Mach 3.2 would subject crews to temperatures of about 450 degrees Fahrenheit. Thus, during a high-altitude ejection scenario, an onboard oxygen supply would keep the suit pressurized during the descent. The cockpit could be pressurized to an altitude of 10,000 or 26,000 feet during flight. The cabin needed a heavy-duty cooling system, as cruising at Mach 3.2 would heat the aircraft's external surface well beyond 500 degrees Fahrenheit and the inside of the windshield to 250 degrees Fahrenheit. An air conditioner used a heat exchanger to dump heat from the cockpit into the fuel prior to combustion. The same air conditioning system was also used to keep the front, nose, landing gear bay cool, thereby eliminating the need for the special aluminum-impregnated tires similar to those used on the main landing gear. Blackbird pilots and RSOs were provided with food and drink for the long reconnaissance flights. Water bottles had long straws which crew members guided into an opening in the helmet by looking in a mirror. Food was contained in sealed containers similar to toothpaste tubes which delivered food to the crew member's mouth through the helmet opening. Speculation existed regarding a replacement for the SR-71, including a rumored aircraft codenamed Aurora. The limitations of reconnaissance satellites, which take up to 24 hours to arrive in the proper orbit to photograph a particular target, make them slower to respond to demand than reconnaissance planes. The fly-over orbit of spy satellites may also be predicted and can allow assets to be hidden when the satellite passes, a drawback not shared by aircraft. Thus, there are doubts that the U.S. has abandoned the concept of spy planes to complement reconnaissance satellites. Unmanned aerial vehicles are also used for aerial reconnaissance in the 21st century, being able to overfly hostile territory without putting human pilots at risk, as well as being smaller and harder to detect than manned aircraft. On the 1st of November 2013, media outlets reported that Skunk Works has been working on an unmanned reconnaissance airplane it has named SR-72, which would fly twice as fast as the SR-71, at Mach 6. However, the USAF is officially pursuing the Northrop Grumman RQ-180 UAV to assume the SR-71's strategic ISR role. Hope you guys love the video. Don't forget to hit the like button and please do subscribe the channel and press the bell icon to all, so you can get the notification on each upload.